Hello students. Today's session is very interesting. We are going to discuss all past questions. Obviously, it's not possible to discuss all past questions, but we will go through a lot of recent questions, and I hope you will be able to get more clear with the topic. And I'm very excited about trigonometry. It has always been a troubling topic for a lot of my students, and if it has been troubling you a lot, then I'm sure this live session will definitely help you become more confident, and next time you see a trigonometric question, it should make you better with solving it. Hi Alan, nice to see you again. And as you told me that trigonometry was one such topic which you really didn't understand in school, I hope I'll be able to help you through this session. So, let's get started. All right. So, the first question we have is definitely the 2-mark question. Sometimes it does come for 1 marks as well, provided they give you the options, okay? So, they ask you x value has been given to you as 2 sine 60 degrees cos 60 degrees, and y has been given to you as sine squared 30 degrees minus cos squared 30. And there is one more information given to that, x squared is equal to ky squared. Now, you clearly see you have x and y given to you, but in terms of known angles, right? So, definitely when you have the known angles, these specific angles are meant to be memorized. We memorize the values because it is quite easy when you know the values, and also we don't have a calculator to use during our exams, right? So, we want to be familiar with each values, and if you don't know, then I can help you recall them. And I have always told that there is a connection between two specific trigonometric ratios, provided the angles are same or there is some sort of connection definitely. So let's get started. The first part, the given information is x equals to 2 sine 60, and I know that sine 60 can be written as root 3 by 2. When the angle is 60 degrees, then the ratio of perpendicular to hypotenuse will always be root 3 upon 2, whereas cos 60 is same as sine 30. Okay, so if you know sine 30, the same value will be for cos 60, because the two angle 30 and 60 adds up to 90. So cos 60 is half, just as sine 30. Now I can simplify this. It simply becomes one of the 2's cancel out to give me the final value of x as root 3 by 2. And clearly I know that x square is ky square. I'll go ahead and find the square of this. To find the square, I have to square both sides what I have, and x squared gives me square root of 3 squared. Square and root, they are opposite, so they cancel out, giving you the root number alone, okay? Whereas the square of 2 is 4. And now let's try the same thing for y. Y has been given to you. Y has been given to you as sine square 30. I know that sine 30 is half, as I said, so I'll take half, square it, minus, now cos 30 is same as sine 60, which I know that it was root 3 by 2, so I'm going to write that as cos 30, and now again that's being squared, so whole squared, okay, you see. And now this is the value of y. Please simplify. Half square is 1/4 minus 3 is the square of root 3, and square of 2 is 4. 1/4 minus 3/4, you are subtracting a bigger value, therefore the answer has to be negative, negative 2/4, otherwise written as negative half. Now again, question says x squared is equal to ky squared. I have to go ahead and square this. Squaring this gives me y squared equals to square of any negative number is positive, so I'll get 1/4. Now question tells me to compare x squared with y squared, or it's given to me that x squared is k times y squared. You can clearly see x squared is 3/4 and y squared is 1/4. So if I have to write it down, then I'll write x squared equals to k times y squared. I'll plug in the values of x squared and y squared that I got, which will give me 3/4 should be equal to k times 1/4. And I always tell this to all my students, when the same denominators are there, you just get rid of them, right? Just the two denominators from both sides can cancel out, giving you k equals to 3. That's it. The value of k has to be equal to 3. That is how you approach question like this. It should not take long, and provided all you're doing is just substituting by the known angles or the ratio of the known angles. And that's it. We got the first answer. We are done with the first question. Moving on, let's try the next question. Now obviously finding questions are more easier as compared to proving questions. I have a lot of proof questions ready too. So before dealing with the tough ones, I want you to get comfortable with the topic. So I'm doing these questions first, okay? Now question tells me to find here. This is the next question asking me to find the ratio of x's to y, provided they have given you an equation in terms of x and y. First of all, always look at the question carefully, and you see something interesting really, that is, you have the same common terms, 2 tan 30 both sides, and instead of 1 plus tan squared 30, you have 1 minus tan squared 30 on the right side. So I would suggest get rid of the commoners before you jump into evaluating by plugging in the values. 2 tan 30 and 2 tan 30 can simply cancel out. Okay, now they want you to find the value of x's to y. I have x times something equals to y times something. How can I get them together? Is, if you understand what I'm saying, then maybe you will follow it from next time. If I tell you AB is equal to CD, then can I say that A upon C equals to D upon B? What I'm doing is I'm just skipping them in a cross multiplication manner. So the numerator here goes to the other side to become the denominator. Likewise, this numerator comes to the other side to become the denominator. So why am I doing this? Is because y is a numerator this side. I'll bring it here and make it as the denominator. Because upon doing so, I'll definitely get the ratio of x upon y directly, okay? And likewise, this is a denominator this side, so I'll take it to the other side to make it the numerator. So this becomes the numerator, while I had already cancelled out the numerator from the other side. So 1 plus tan squared 30 divided by 1 minus tan squared 30. Hello, Rizwan. Now, because I've already got the fraction much simplified now, yeah? I have cancelled out the common terms and I have just two things to deal with. So obviously at this point you have multiple things to do, but my suggestion, because the terms are same, you want to plug in the value of tan 30 and square it. If you know, then tan 30 degrees is equivalent to, or the ratio of the opposite to adjacent or perpendicular to base is 1 by root 3 when angle is 30 degrees. So thereby, upon squaring this, I simply get that tan square 30 has to be the square of 1 is 1, the square of root 3 is 3. So I'll just plug in that value, 1 plus 1/3 upon 1 minus 1/3. What is 1 plus 1/3? It has to be an improper fraction because this 1 becomes 3 upon 3. So 3 plus 1 is 4. It becomes 4 upon 3 minus, not minus, divided by 1 minus 1/3 is simply 2/3. So now when I have to deal with this, my denominators are again same, so get rid of it. All you have is to divide 4 by 2, answer is 2. Isn't that simple? It does look complex. Yes, Alan, you're right. It has to be 2:1 because I got the answer 2, but because we are finding the ratio, so it has to be written as 2:1. Perfect. Easy, yeah? So this is how I solved this question. Obviously, you can have a different approach, but I figured out this could be the easiest one or the shortest one. Moving on, question 3. So with each question, I've tried my best to level up and challenge you with each question here. So let's hope you get the answer to this question as well. This may not be that hard, but obviously you want to approach in the simplest way possible. Given to you is sine B, one of the angle B, which is an acute angle definitely because it's a right triangle ABC, right angle at A. So B and C has to be acute angles. So sine B is 1/4, okay? Find the value of sec B. Now again, multiple ways you can do it. But think about sec. They're asking for sec and given information is on sine. What's the best way you can connect sec and sine? Is knowing or trying to recall the fact that sec is just the reciprocal of cos. Yeah, it is just the reciprocal of cos. So sec B can be written as 1 by cos B. Okay, and I know the one relation that connects sine and cos, which is just sine square B plus cos square B has to be 1. For given angle B, the square of the sine of that angle plus the square of the cos of the same angle has to be 1 every time. Thereby, when I know the sine B value, I can say that cos square B can be written as simply 1 minus sine square B. Whatever value of B you have, you want to square it and subtract from 1. Now, the square of 1/4 is 1 upon 16. Yeah, subtracting anything from 1 is the easiest thing. Don't ever go ahead and just try a lot of things, okay? It's just 1 minus 1 by 16 is just the difference of the two values, the numerator and the denominator, which is 15. So answer has to be 15 upon 16. Yeah, that's simple. You got the value of cos square B. So now note that if you want to find the value of cos B, you have to take the square root. Now you must be wondering why not take both positive and negative? Because a square, when it gives you, or when there is a square equation, then you have two possible answers. But remember that this question clearly talks about acute angles, and for all acute angles, the ratio is always positive. Okay, so don't think about getting that plus minus. It's all about taking only the positive values. So cos B is square root of 15 upon 16. Clearly 15 is not a square number. I have to write it as root 15, while 16 is a square number. Square of which number is 16? Definitely 4. I got the value of cos B, right? And now I want to find the value of sec B, which is just the reciprocal. So just find the reciprocal of this, giving me that sec B has to be 4 upon root 15. That's interesting, yeah? So this is how a question like this can be approached using the identity, okay? Trigonometric identities. There are 3 identities that connects all the 6 trigonometric ratios. I hope you're aware of that. And with every question, we will try to see if they are applicable. We will definitely use it. So that is how I did this question. Moving on, I believe that trigonometry, I really want students to be confident with this topic, and it's quite fun. Had there been no trigonometry, people would have been thinking about how they could actually measure the height of the tower. Yeah, they might have thought of using a proper scale for that, but you can always bring trigonometry out there, and it is very, very handy. You want me to explain the identities? Well, I can do that definitely. and I'm very excited to share this identities. It really comes from, from the basics of Pythagoras theorem. Let me tell you, trigonometry was there, or it came into action only because of Pythagoras theorem, or because there was Pythagoras theorem already, people could think of trigonometry. Okay, as you suggested, I should talk about all the trigonometric identities. Well, I would want to do that, definitely. All right. Okay, let's talk about the identities. The first identity, okay, first of all, let me begin with the triangle. In a right triangle, we have that Pythagoras theorem valid, right? When Pythagoras theorem simply tells you that the square of the first side and the square of, so basically you have three sides in a right triangle, and with the help of Pythagoras theorem, we know that the square of the first side and the square of the second side, the two sides added up, are perpendicular to each other. So the two perpendicular legs, when I take their squares and add them up, that should give me the square of the third side. That's Pythagoras theorem, right? Now the first thing I'm going to do is I'm going to take this entire equation and divide by the square of the hypotenuse. What happens if I'll do that? My a square gets divided by c squared, and note that because both the denominator and numerator shares the common power, I can write it as the square of the two. Some of my students, they just go and cancel out the squares, okay? Don't ever do that. That does not make sense, ever, okay? So, like for example, think about 3 by 4 and think about 3 square by 4 square. Obviously, if I'll cancel out the squares, it becomes 3 upon 4, but that's not true. Yeah, 3 upon 4 is not the same as 3 square upon 4 square. So thereby, I have to give it as a common power. Likewise, I'm going to do the same thing for the second one, b upon c, the whole square. So c square divided by c square is 1. Now what is a upon c? A is the opposite. Let's say my angle is here, my theta is here. So with respect to this angle, a upon c is nothing but just the ratio of the opposite, or the perpendicular, to the hypotenuse. In terms of theta, if I have to write that, then that is sine square theta. Now square, because it's already getting squared, okay? Likewise, b upon c, that is the ratio of cos, right? Cos of this angle theta, because b is the base and c is the hypotenuse. So base upon hypotenuse is always cos, so that is cos square theta. We just got our first trigonometric identity. Sine square theta plus cos square theta equals to 1. Now we can do the same thing for all the rest of the identities. Okay, we can divide by b square, or we can divide by a square, and we'll get everything. But there is the other way I can do it, is I'll just consider this one continuously, okay? So sine square theta plus cos square theta equals to 1. Now let me divide this equation by sine square theta. What happens if I divide this by sine square theta? Sine square theta divided by sine square theta will be 1. Cos square theta by sine square theta can be written as cos by sine the whole square, right? And equals to 1 by sine square theta. All I'm doing is just trying to prove the identities, okay? So Neeraj is saying that he can't understand. Well, one of your friends actually told me that I can help him with the square identities of trigonometry. So I'm just helping you all to understand how these trigonometric identities come into play, like where are they even coming from, okay? So all I'm saying is I am taking the first identity, sine square theta plus cos square theta equals to 1. I divided this entirely by sine square theta. If I'll do that, upon dividing same two terms, sine square theta, I got 1. I wrote cos square theta at the top as it is and divided by sine square theta, or because both of them share the common power 2, I wrote it as cos by sine the whole square, and equals to 1 by, because this side it was just 1, so dividing 1 by sine square theta gives me 1 by sine square theta. I'll think about that in the next step. And now I'll write that 1 as it is. Now think about cos to sine. What is that? Cos to sine is a ratio, I can write that as cot square theta, cot square, opposite of tan, okay, because tan is always about the ratio of sine to cos, while cot has to be the reciprocal of tan, so it makes sense that cos upon sine can be directly written as cot square theta. So equals to 1 by sine square theta is nothing but just cosec square theta. This gives me my next identity. In fact, I tell my students how to remember this is just like, it's like subtracting the big letter words or, higher letter words with the small letter words, and that taken in order, their difference is always 1. This gives us the second identity now. That is the second trigonometric identity. Now similarly, now as I told you, there is other way I could have done it. I could have taken the same Pythagoras theorem, okay, and I could have divided it by a square at a time, b square next, and c square, like that is what I could do. I divided by c square here to obtain my first rule. I could have divided the same thing by other variables. So I can show you that. So again, using the same relation, sine square theta plus cos square theta equals to 1, if I would have divided by cos square theta, then that would have now given me the next identity. If I would have divided the whole equation by cos square theta, which expression I'm taking is the first one I got, sine square theta plus cos square theta equals to 1. I want to divide this entirely by cos square theta. Now what happens is, again, I'm dividing sine by cos, so I will write that as sine theta by cos theta the whole square, okay. Again, cos square theta divided by cos square theta has to be 1. So I'll write that 1, and I already have 1 on the right side, divided by cos square theta. Sine upon cos, right now as I said, sine upon cos is just tan, right? The ratio of sine and cos is equivalent to tan. So tan square theta it becomes, right? You write tan theta whole square or tan square theta, it does not make a difference. It is just the same thing, but this is more appropriate, okay? Plus 1 equals to, what's the reciprocal of cos? Sec. So I just got the third trigonometric rule telling me that tan square theta plus 1 is always equal to sec square theta. Otherwise, you remember this is again, if you want to remember this, then it's always going alphabetic. You can think sec square theta minus tan square theta is equal to 1, QRST. Yeah, it's going alphabetic here. The reason why you need to remember the order is because you're subtracting, and a minus b is not the same as b minus a. So it has to be in the same order, right? Sec square minus tan square. Because for sine and cos, you can write in any order because they are being added. You either say cos square theta plus sine square theta or the reverse of it. It is still the same thing, but it is not the same for the other two. They are subtracting, okay? So make sure you remember this and you will not have problem dealing with trigonometric proofs. That's it. These are the 3 trigonometric identities. If there is anything else you want to understand in trigonometry, I would love to explain that. And I hope, Alan, it made sense to you. And you could even try with the same Pythagoras theorem. You could have divided by a square, the entire equation. Yes, Alan, I'm glad to hear that you have understood things here. Please tell me if something like, why is the value root 3 by 2? Why is the value 1 by 2? If you have such questions, I'm open to answering all those as well, okay? So let's get back. I have shown you how these trigonometric ratios or trigonometric identities are obtained, and using them, we will have to use them at a time, and I will show you how exactly you can use them to prove certain things. Obviously, you cannot use everything in one question, okay? It depends what the question is asking, and we have to manipulate things likewise. See, wow, this is interesting now. See, use the identity. I just did this, and Alan's question actually comes here. Use the identity sin square a plus cos square a equals to 1 to prove that tan square a plus 1 equals to sec square a. Now, if you'll have some confusion about how to begin, or, you know, what exactly should I divide this equation by, then I don't think there should be such an issue, because you want to obtain tan first of all. So tan is obtained by taking the ratio of sine to cos, yeah, and I already see that sine. So I will divide this entire equation by cos square a. Here theta is a, so I have to use that as well, okay? I have no other options. So sine square a, I'm dividing each term at a time by cos square a. Sine square a divided by cos square a will simply give me, or I'll just write it first because, you know, they want you to show your steps during your exams, right? So sine a upon cos a the whole square plus cos a, or yeah, I can just write it as cos a upon cos a the whole square equals to 1 by cos a the whole square, of course, because I mean it's optional whether you write whole square or you write cos square a alone, does not make a difference because you have 1 at the top. So sine by cos is tan, so that gives me tan square a. Cos upon cos is 1, so 1 square is just 1. 1 by cos, reciprocal of cos that is, so which is sec square a. Yeah, I just proved it. Proved. And this kind of question they ask for 2 marks, sadly, okay, just 2 marks, but of course you don't want to lose that 2 marks, because in mathematics it's kind of possible. I always tell this, scoring 100% is kind of like, you know, you can challenge yourself, and 100% might be a little tough because 90, 95 is still easy, 98, 99 can also be easy. To get that 100%, you just need to be focused, completely focused into your paper, into each question. Don't think about food in between, okay? Just, you know, just keeping your head straight to each question and giving full attention is the only way you can score that 100%. And always aim for that, nothing less than that. Question is continued here. Hence, find the value of tan a when sec a is given to you as 5 by 3. Any question that says hence something, then it always means what you got as your part A answer. Use that and then proceed. That's the meaning always, okay? Hence do this, hence evaluate. So it's always connected to the part 1 of that question. Tan A is what they're asking you to find. Sec A has been given to you 5 by 3. So definitely we have got the relation that tan square a plus 1 is sec square a. So definitely I'll find the value of sec square a by simply plugging in the value of tan a and whole squaring it. Okay, they are asking me the value of tan a. Sec a has been given to me. So obviously to find the tan value from here, you would just take that 1 to the other side. Thereby you will write it as sec square a minus 1. Sec a has been given to me as 5 by 3, so I'll just square 5 by 3 and then subtract 1. 5 by 3, when you square 5 by 3, what do you get? 25 upon 9. Now subtract 1. Again, subtracting 1 is very simple. 25 by 9 is an improper fraction, so we can subtract 1 by simply finding their difference. 25 and 9, they have a difference of 16. So answer is 16 upon 9. That's the value of tan square a. Note that. And question is asking you to find sec a, not sec square. Or question is asking you to find tan a, not the square. So I have to take the square root of this, giving me tan a has to be the square root of 16 is 4 and square root of 9 is 3. tan A is 4 upon 3. Isn't that simple? That is how you use the identities, and this is what exactly you are supposed to do for questions like this. Neeraj, is there any problem? Did you not understand any part of the question? Please let me know. All right, I'll just do the next question then. I will come back to you, Neeraj. Okay, and now comes some of the interesting question. Honestly, these are the kind of questions which trouble my students, and obviously it does trouble some of you, and it's okay, okay? Like, you are studying trigonometry for the first time in class 10, and question like this can just screw your head. But there is a way you can approach questions like this, and there has to be a strategy. They have given you, let's read the question. A sec theta plus B tan theta is equal to m. B sec theta plus A tan theta is equal to n. Prove that A square plus n square equals to B square plus m square. Now obviously it looks so messy. Why? Because A is here, B is here. Obviously, how can I get A square and n square now? And n is somewhat here, so how can I even think of getting this A and n together? So don't ever start with the left hand side and the right hand side for such questions, okay? When they have connected two trigonometric ratios with some coefficients a, b, and they have also given you its equivalent to m and n, don't ever go ahead and think about substituting the variables here. There is a different approach. You have clearly seen it's a square, n square, b square, m square. Because of the squares, I'm pretty clear that I might have to square the given equations. So let's begin with the first equation. A sec theta plus b tan theta is equal to m. That's given to me. So because I see that my proving part, okay, the part that I want to prove has got the squares, I want to square the entire equation. There is no way you can just square the individual terms. So I will just square it both sides. So squaring both sides, remember when you square it, don't ever go ahead and square the individual terms again, okay? You will square the whole thing whenever they are added or subtracted. But whenever they are multiplying or dividing, yes, you go ahead and just square them individually. Remember that. Upon squaring this gives me m square. So let's expand the brackets. Obviously, when you have two things, binomials, right? They are binomials because the two terms cannot be simplified further, and I have them added up. So I want to find the square of that. Always go ahead and use that favorite identity, a plus b the whole square. So the square of the first term, the identity tells me to square the first term. So because I have two things, a and sec square or a and sec theta, they are multiplying. So two things multiplying and I have to square them. I will go ahead and individually square them. All right. Plus the square of the second term, b square tan square theta, plus because of a plus b the whole square, I have to add one more term, that's just the double product of the two. So upon doubling the product of this, a and b, they can multiply together with that 2, giving me 2ab times sec theta tan theta. I'm just writing the theta part later, okay? And then that gives me m squared. And now a square sec square theta plus b square tan square theta plus 2ab sec theta tan theta. And that is nothing I can really simplify here. So I will take a pause. I'll mark this as equation 1. If you have, because you have the second equation too, I will write the second equation and I'll follow the same process as I did for the first one. I will take the whole square both sides. And now, again, follow up same thing. B square sec square theta plus a square tan square theta plus double the product of the two. I believe the question was actually supposed to be minus. I think the question has a problem. This question was supposed to be minus here. A sec theta plus B tan theta. Or I think even if it is plus, okay. I think it is plus only. 2AB sec theta tan theta. I just get the same expression, okay. There is one thing in common between the two equations I got, and that's the 2AB part. Now, because I have something that I can cancel out, I will subtract the two equations. Okay? I will have to go ahead and subtract them. Now, subtracting the two equations, how would I do it? If you were to keep them together, then please see that upon subtracting the first and the second term, because I think you are understanding which two equations I am subtracting, this one and this one. Okay, I am subtracting first minus second, so obviously I see there is a common term, sec squared theta. Okay, these are the two equations I am subtracting. So sec squared theta is a common part. So when you have common part, you just write it outside as a factorized form. I am subtracting the first minus second. Okay, because I am subtracting first equation minus second equation, so I will get a squared minus b squared here. Alright, I hope that's making sense. Similarly, if you look at the second part, tan squared theta is common. So tan squared theta will remain as it is, while I am now subtracting b squared minus a squared. And now this term, equal and opposite, it becomes upon subtracting, yeah. So obviously equal terms upon subtracting cancel out each other, giving me m squared minus n squared. Now, there is something, we are very close to it. If you look at the two expressions you have, both the expressions are kind of similar, but they are opposites. One is in the form of a minus b, while the other is in the form of b minus a. So in that case, what should I do? Is I will take out that negative outside and write it opposite inside. Meaning, I am writing the first part as it is. Now, instead of this b squared minus a squared, if you want to write a squared minus b squared, all you want to do is you want to make a squared positive and b squared negative. That can be done by simply multiplying by negative or taking out that negative part common. Because if I bring that negative outside, now I will have to multiply both terms by -1. Okay? So thereby a squared becomes positive and b squared becomes negative. Alright, I hope that makes sense, because if I have 2 plus 3 and now I want to write 3 in terms of negative, then I have to make it as 2 minus of minus 3. Yeah? If you bring negative out, then you will always have to write it opposite inside. So that is what I am doing here. Once I did that, now I am very close to what they want me to prove. You have two expressions again. Out here you have two expressions. Both the expressions have a squared minus b squared part common. Second tan will not cancel out, Alan. What you mean is, see, the two expressions are completely like, okay, understand one thing. If you have 3a minus 2a, you never cancel out a and write down just answer as 1, right? The answer has to be 3a minus 2a is 1a, right? It's like 3 kg minus 2 kg, answer is 1 kg. Of course, kg will not cancel out. So the same logic here, I'm saying is, because they have the different multiplier, a square and b square, obviously it's like a square kg and b square kg, for example. Then the answer has to be a square minus b square kg. That is what I'm doing. I hope that is making sense. Okay, so I just cancelled out the 2ab part because they are all equal and opposite, but the others are not equal, they are just different terms with different coefficients. So as I gave you an example, 2x minus 1x is just x, it's not 1. Okay, keep that clear. So now because I have two expressions where a square minus b square is common, so upon writing a square minus b square common outside, I'm factorizing them. So a square minus b square is out, giving me sec square theta minus tan square theta. Now I just showed you, the rest I'm copying it as it is. I just showed you the identity. S minus t, s square minus t square is just 1. And now we just got a square minus b square, because that whole bracket has turned out to be 1. It becomes a square minus b square equals to m square minus n square. And now I'll bring the negative terms like the question wants me to write. So this minus n becomes plus by bringing it this side, and this b goes to the other side to become positive. There is already a positive m square term. And congratulations, we just got the exact thing the question wanted before, even without having to take the left hand side or right hand side of the equation. I just got the same identity they want me to get. A square plus n square equals to b square plus m square. Okay, that common part should be very clear to you, Alan, because it is not just you that you who thinks that way. Okay, it is kind of common. It's a common misconception. So just think this sec or tan just to be like your variables, like x. It's like a square x minus b square x. So it cannot be like a square minus b square alone. They have to have that common part as it is. It's just like factorizing and bringing out the common part. That's it. This is one of the toughest question, I guess, amongst all the questions we've done so far. And this is exactly what you are supposed to do. Moving on. I hope you are understanding it. I hope you are enjoying it. And it's more about using the right approach. Okay? So that is what I'm trying to work on. I want your approach to be fine, effective, efficient. Okay, so that is what I'm working on, definitely. So this is how we did it. Now moving on to the next question. Prove that sine a plus cos a, so the expressions are all the same, sine a plus cos a at the top, sine a minus cos a. Likewise, the other side what we have is just the reciprocals. Now the first thing that should come to your mind when you see such fractions is to make the denominators common. So in most of the cases that works. Okay, you want to make the denominator common so that, because the denominators are completely different here, a minus b and a plus b. Don't ever think that there will be sine a cos a common here. Now if I'll ask you x minus y and x plus y, what's the common denominator for them? Because we don't know the values, right, x and y, we will simply take their product as the multiple, as the lowest common multiple. All right. So in this case also we will follow the same thing. We will consider taking the numerator, we will take the denominator common. To do that, I have to make sure that the first fraction is multiplied with the opposite denominator completely, right? That is what you do. Similarly, you multiply the second fraction completely with the opposite denominator. So my new denominator will simply be sine a minus cos a times cos a, or sine a plus cos a. Now because to write this fraction with both terms in the denominator, I have to make sure that I am multiplying the numerator with the same expression, right? Because the denominator here was just sine a minus cos a, and now my new denominator has that additional term multiplied. So I have to go ahead and multiply the same thing to the top. And because we have sine a plus cos a multiplying with this sine a plus cos a, the opposite denominator, what happens? It just becomes sine A plus cos A the whole square. Now likewise, because this numerator is oppositely multiplying with the denominator, thereby it becomes sine A minus cos A the whole squared. It's all about proof, so we can always say this is our left hand side, and my left hand side has now simplified to giving me this fraction with a common denominator. I hope this is making sense. And now, what do we have? We have the numerator pretty complex, so I want to simplify them. A plus b the whole square again gives me a squared plus b squared plus 2ab, so 2 sine A cos A. Likewise, my other bracket will expand to give me sine square A square plus b squared minus 2 sine A cos A. Whole thing divided by my new denominator. Now if you look at the denominator carefully, then again it's like algebra. Algebra is everywhere. Yeah? You have the denominator in the form of a plus b times a minus b. That's the sum multiplying with the difference. That gives me nothing but just the difference of the squares of the two. Meaning a plus b times a minus b is always equivalent to a square minus b squared. So sine square A minus cos square A. Now go to your numerator. What do you see? You see a pair of equal and opposite terms. 2 sine A cos A cancels out with minus 2 sine A cos A. They are equal and opposite. So what I really have at the top is now sine square A plus cos square A, which is 1 from that identity I just proved. Again, I have the other pair here, sine square A plus cos square A. That gives me another 1. And now at the bottom, sine square A, if I write it as it is, because I know that upon proving it in the question, they have kept that sine square A, that is what I want to prove in terms of, right? So I don't want that cos term because there is no cos at the bottom. So instead of cos square A, what can I write? Because sine square A plus cos square A is 1. I can write it as cos square A equal to 1 minus sine square A. Yeah, definitely. So obviously the identity might not be helpful in just the way it is. We might have to manipulate it whenever needed. So instead of this cos square A, I will go ahead and write down this. I will write down all in terms of sine. Okay. So instead of minus cos square A, I'll keep that minus as it is. I'll keep that minus as it is. Right, Rohit, you are correct. Sine square minus 1 is the other way to represent. A little not correct because the sum is 1, na? So you want to subtract from 1, okay, not 1 from the cos or sine, okay. It will be a little wrong to say that. So it will be 1 minus sine square. All right. So instead of cos square A, I will write it as 1 minus sine square A. Or if you are saying that instead of cos square A I should write it, then maybe, yes, I think if that is what you meant, then you are right. But out here it may not be familiar to all of them. That is the reason I just kept that negative outside as it is. And I just write it as 1 minus sine square A. Alright, so at the numerator all I have is 1 plus 1, which is equal to 2. And then at the bottom all I have is sine square A minus 1 minus minus plus. So sine square a. I got 2 sine square a at the bottom, so I can write that as 2 sine square a minus 1. Thereby, that is what my RHS should be. That is what my question told me to prove. 2 sine square a minus 1. Hence proved. I hope that made sense. And Rohit, what you said, sine squared minus 1 will be the identity I can actually use for negative cos square a. Okay, so definitely I should have done that. I mean, that is also an option, but I just considered it doing the conventional way because I thought it might be confusing to my other students. So yeah, of course you can just go ahead and definitely you can go ahead, instead of directly writing minus cos square a, you can take that cos square a to the other side and you will get, so if you would have taken cos square a to the other side, that is when you would bring that minus a or 1 to the other side, right? You would bring 1 to the other side, becomes minus 1, and then this cos goes to the other side, it becomes minus cos square a. Alright, so instead of minus cos square a, I can always go ahead and write down sine square a minus 1. That would have again given me the same answer. So I would have got sine square a plus sine square a, which is 2 sine square a minus 1, as I got it here. So yeah, definitely. This is how I approach this question, and this kind of question will now be there for 3 marks, 3 to 4 marks sometimes, okay? So yeah, standard, I mean, the question paper I took it from, it was for 3 marks. So this is how you can get your 3 marks fully back, like you just want to follow algebra, nothing else. Okay, now this is one question that can screw up a lot of your head, honestly. It's kind of weird because you have power of 4 given to you. All right, Biomers, welcome back. I know that you were there in one of our previous sessions, so I hope this is fully about trigonometry. Okay, I think going topic wise can be more helpful, and if there is any topic, or sorry, if there is any particular concept that is still not clear to you from trigonometry, I am delighted to talk about that. So let's talk about this question for now. Question 7. It says sine theta plus cos theta is x. Now prove that sine to the power of 4 theta plus cos to the power of 4 theta. Now a lot of you who have already been dealing with question like this, then obviously there are multiple ways again doing this kind of question. But because sine and cos, if I know that sine and cos do have an identity that I can connect with, and they have already given one equation in terms of x. They want me to prove sine to the power of 4 and cos to the power of 4. I can think about getting these power of 4 only if I take the main identity of sine and cos. So I have 2 things to deal with. I have one thing that is sine theta plus cos theta is equal to x. I'll deal with that. And I'll also deal with sine square theta plus cos square theta equals to 1. It will be very handful here. Now, let's get started with this question. All right. First of all, I know one thing, that to obtain a power of 4, I must have that square terms. That is the reason I have one thing to talk about, that is sine square theta plus cos square theta is equal to 1. Right? I'll begin with this identity. Again, it's not mandatory for me to take the left hand side and then start with left hand side and do the right hand side. Okay? There is a way I can directly approach question like this. This is one identity I'm going to use, and one of the identity has already been given to me, sine theta plus cos theta is equal to x. So wherever you begin, it's the same approach. So I want to start with this one. Sin theta plus cos theta is equal to x. Okay, if I'll take this and if I square both sides, what do I get? Again, as I told you, squaring is not done individually when it is plus or minus. Okay, so you have to take it as whole square. So I'm writing the formula directly. Okay, sin square theta, square the first, square the second, and add the product, double product of the two. So plus 2 sin theta cos theta. All right. Now if I'll take the square other side, it gives me x squared. So you know it already that sin square theta plus cos square theta is equal to 1. So if I write 1 instead of that two terms, instead of those two terms, if I write 1 out there, then it just becomes 1 plus 2 sin theta cos theta equals to x squared. Now 2 sin theta cos theta can be figured out. How much will that be? Gives me x square minus 1. I bring that 1 other side. Okay. Now from here I can say that sin theta times cos theta is equivalent to x square minus 1 upon 2. I hope that made sense. Moving on, I have the next equation, the main standard equation that connects sin to cos. Now I'm going to take this and whole square both sides. Okay, again we are taking the square both sides. Hello Ayush Singh. I hope you are enjoying this trigonometric proof. So moving on, obviously I want to square this equation. How would I do it? Again follow the same technique. Square the first. When I square a square term, definitely it gives me power of 4. I hope that's not confusing. Yeah. If I square the cos square theta, it gives me cos to the power of 4. And to that I want to add twice the product of the two. So plus 2 sin square theta. Note that the things I'm squaring is sin square theta and cos square theta. I'm squaring them. So this is my A, this is my B. So I have to write them 2AB. So 2 sin square theta cos square theta equals to square of 1 is 1. Now remember from the previous equation I did get the value of I got the value of sin theta cos theta, right? So that might be helpful here now, because I might want to take that term 2 sin square theta cos square theta to the other side, make it negative, and instead of not writing, because two numbers multiplying are indulged with the same power, I can go ahead and write them as a common power. So 2 sin theta cos theta whole squared. And note that this is what question is asking me to find, this part. So I just kept that part on the left. Okay. I kept that part on the left, and then on my right side I have to get the exact expression they want me to get. So I am not writing this left hand side, I'll just solve for the right hand side. 1 minus 2 times the square of what they want me to take. So the square of x square minus 1 will simply be x square minus 1 the whole square. This is what I'm trying to use. So square that 2 at the bottom, which gives me 4. That 4 and 2 cancels out to give me 2 at the bottom now. I can take that 2 as the entire common denominator, giving me, instead of this 1, I will go ahead and write 2, because I'm making my denominator common. So this 1 now becomes 2 upon 2, right? So I'm writing 2 instead of that, minus the bracket part is just x square minus 1 the whole square. Is this what they want me to get? Of course it is. 2 minus x square minus 1 the whole square upon 2 equals to RHS. See, I did not take any part of the left hand or the right hand. I just figured out what they are asking me, and I just approached it in the simplest way possible, because they had given me one equation connecting with x and I know one other equation already. So this is how I worked out with this question. Again, a question like this is just for 3 marks. These many steps you will be expected to do, and yeah, that's not a lot, but still you can crack it out like this. I hope this is making sense, and I hope the questions here are kind of challenging for you, because these are the kind of students, kind of questions my students often struggle, okay? And I know that it is quite I don't get you, Piyush Kumar, and I just hope that this kind of questions, next time you're solving a question like this, you will remember how I did it, and you will try to recall and solve it all by yourself, because questions are connected. You will have questions somewhat, or something like this, or maybe modified a little bit, but typically like this. What type of questions usually come in competitive exams related to trigo? It's more about using the complementary angle property, like when you use sine theta, sine squared 30, evaluating questions about putting the values of sine 30, sine 60, or I have even solved a lot of competitive exam based questions in many shorts. You can try them, you can see them. They will give you a bunch of things like tan, especially I've seen this question, okay, where they give you, they'll ask you to solve for very simple question. Like this is a very common question, not just for competitive exam, but even a class 10er should know how to do a question like this. What they'll give you is they'll give you tan 47 times cot 43. Evaluate. Now this is a pretty simple example I've considered. So you should know a question like this will now given in many terms, like tan of 1 times tan of 2, okay, and like that, okay. So now if you ever have a question like this, I'll come to your question, Piyush, hold on. Tan 47 times cot 43. If there is a question like this, then you know that tan and cot, just like sine and cos, they have that relation for complementary angles, like angles adding up to 90 will have the same sine value and the cosine value, right? The same thing is for tan and cot. The same thing is for sec and cosec, like sec theta and cosec of the 90 minus theta, or cosec of the angle that adds up to the previous angle to make that 90. Those two will give you the same value. So cot 43 can be written as tan of 90 minus 43. Why? Because they will be equal. Okay. So now 90 minus 43 is same again 47. So you will get the answer as tan 47 times tan 47, which is just equal to tan square 47. This is just an example, but if you'll go through my shorts, some of my shorts, then you will definitely see the kind of questions for tan. One common question that I have seen is about giving you tan of all angles, like tan of 1 degree, 2 degrees, 3 degrees, okay, 4 degrees, and so on. It goes up till tan of 87, tan of 88, tan of 89. That is one common kind of question, and it looks so tricky. Yeah, it goes till like 89 from 1. So find the value. So how exactly a question like this is approached? Tan 1, you don't know what that value is, but if you look at the last angle, tan 89, you can write that as cot of 90 minus theta, because 90 minus 89, cot of this angle and tan of that angle 89 will be the same for two complementary angles 89 and now obviously 90 minus 89 is just 1, so cot of 1 you get. Okay, similarly tan of 88 you get cot of 2. This way what happens? Your tan 1 and cot 1 will cancel out because they are reciprocals. Cot 1 can be written otherwise in terms of tan as 1 by tan 1, right? Or 1 by tan 1 degrees. So everything cancels out, okay, because they will all be equal and opposite. Tan 2 and cot 2 will be reciprocals of each other. That is why everything cancels out, giving you the answer just 1, because the last value, the middle value is tan 45. So that tan 45 is actually equal to 1, giving you answer 1. Okay. So this is the kind of question they usually ask you. And Piyush has a question for me. Okay, somebody has already answered for Piyush. Trigo is important because it can be helpful to find distances, angles and heights in real life situation like physics, engineering, most important navigation, and I think in higher level of maths too. That's amazing, Rohit. Yes, you're right. But if I have to tell you why trigonometry is important, had there been no trigonometry, you would have been still wondering about how to connect angles with sides. Because till now you just knew that sides are connected by Pythagoras theorem, angles are connected by that angle sum property of angles being the total in triangle is always 180. Yeah? But there was no such concept till now which would help you find the missing sides with the help of angles, or sides or missing angles with the help of sides. Imagine you're somewhere here and just by looking at the tower you can find the height of the tower using trigonometry. There is no other subject or there is no other concept that can actually help you find that. Okay, and obviously this is the reason why trigonometry is so powerful. Okay, and now the fact is, why trigonometry for just triangles? Because if you know for triangles, you can know for any polygon, right, or any solid or any plane figures. Because if you know for triangle, then you join different, or you have many other points, then you always get multiple triangles. You can always divide a polygon into multiple triangles. So that is the reason why trigonometry is so powerful, because only with the help of this angle you can figure out this side, or with the help of this angle anything. Like in a triangle you have 6 components, I think I can call that, maybe, because there are 3 sides, 3 angles. So if you know, at least if you know one of the angle and one of the side, then you can find anything you want for that triangle. Isn't that interesting? Yeah? And once you know for a triangle, you can find for any shape you want. So you come to higher level and you will understand how important it can be further. But my simplest answer would be, you would be still wondering. Without trigonometry, you would have been wondering how to actually measure the height of a tower just by looking at that tower. Okay? So it's really interesting actually. So that is my explanation. So yes, in fact you will all right, Piyush, you did not understand. Okay. Well, you're in class 9, so don't worry about it. Trigonometry is one topic which will help you connect the sides and the angles. If you're in class 9, you have no clue about it, right? But if you come to class 10, then you will see how this sine, cos, tan, they are just the names of different ratios, okay? Because if I have one triangle, if I have a triangle like this, and now I divide this triangle into multiple triangles, I can divide it into many triangles as I want, okay? Keeping the base the same, or keeping the base parallel like this, I can divide it into multiple triangles, keeping this angle fixed. So I got so many triangles, yet if these triangles are drawn, then they must have some connection, yeah? That connection, you want to understand that connection just by understanding the angle here. So this angle will actually help you find all the sides that you want, provided which triangle you are considering. It's so powerful in that way actually. Don't worry, in class 9, things are quite easy maybe, and trigonometry is not going to be tough, honestly. It's like there is one topic called applications of trigonometry. I think when you'll see the questions from there, you will understand how exactly, I mean, that is applicable. But it is really good that a class 9 student has some curiosity, and he is willing to understand things even though it's not a part of his syllabus. That's amazing thing, okay? always keep that part up. You know, you are always learning things. I mean, even if it's not even if it is not in your syllabus, doesn't matter. Yeah, it's more about understanding. Class 10 is not hard, Piyush. It's going to be more interesting than class 9 actually. Class 9 becomes a little boring with lots of proof and all about proof. You know, you have proof in triangles, proof in circles, you have proof in parallelograms, everything there is proof. But in class 10 you have more like solving things, applications of trigonometry, you have arithmetic progression, you have proof part is there. It's again, triangle is going to come back, don't worry, but you will be studying different type of triangles. So it is actually going to be helpful. Don't worry with that, okay? Class 10 is much interesting than class 9, according to me. If you'll ever ask me, then I would say the odd number classes are much weirder than the even number classes, okay? Like BPT, yes. BPT is also known as Thales theorem. Thales is one person who actually measured the pyramid of Giza, if I'm not mistaken, okay? He measured the height of pyramid of Giza by just looking at it, or by taking the ratio of the shadow and the, you know, he actually found the height of the pyramid of Giza by taking the length of the shadow, or basically he actually used that concept of similar triangles. That's just a fun fact to let you know. Okay, I have one last question from trigonometry right now, and this is one question. This is just the proof that I was doing before. If there is anything you want to understand in trigonometry after this question, you're free to ask. Okay, so I have this last question to do, and I am hoping that with these many questions I have done enough of revision, enough of practice for you, and I'm hopeful that this will actually help you during your exams, okay? And I will do topic wise. I have a lot of topics to go ahead and do. If you have any recommendation about which topic should I do next, please go ahead and suggest. All right, the last question of trigonometry. Prove that cos theta minus 2 cos cube theta upon sin theta minus 2 sin cube theta plus cot theta is equal to 0. Now, because the right hand side is completely 0, I want to take the left hand side and begin with proving the left hand side. All right. Left hand side, let's begin. The left hand side has given me clearly that there is cos theta minus 2 cos cube theta at the top, divided by sin theta minus 2 sin cube theta plus cot theta. Now, I am assuming that 80% of the students might go ahead and think about doing this cot, or maybe they might think about, okay, there are many assumptions I can make, okay. Some of you might think about making this sin theta minus 2 cos cube theta as a common denominator, or maybe some of you might think about converting that cot in terms of cos and sine, which will be a good idea. Why? Because if I write cot in terms of cos and sine, then obviously what happens is my whole expression has just two variables now, cos and sine, okay. So that is a fair way I can do it, and if that is coming in your head, you should proceed likewise. If you look at the two numerators, the first fraction if you look at, then you clearly see in the numerator that cos appears twice. Likewise, sin theta appears twice in the denominator. So when you see two terms with something in common, the first thing that should come to your mind is factorization. So you might want to factorize and write down cos theta out, okay. If that is taken out common, then we are just dividing both of the terms by that cos theta we wrote outside, yeah. Cos theta divides cos theta gives me 1. Cos theta divides cos cube theta to give me cos square. So that 2 remains as it is. So I'll write 1 minus 2 cos square theta. Whole thing divided by, again I'll follow the same thing, sin theta 1 minus 2 sine square theta, because one of the sine is already out. Now, if you are also someone that would think that this cot could be simplified to cos upon sine. Cot is the reciprocal of tan. So tan is simply sine upon cos. So reciprocal of sine upon cos is cos upon sine. So you can go ahead and do that. Now you look at the two denominators, they do have something in common. When two denominators have something in common, you write the commoner part once and the non-common part as it is. Yeah? Just like, for example, if you have 1 upon 6 and 1 upon 8, the LCM of this is not 48. What is it actually? Because 6 is 2 times 3 and 8 is 2 times 4. The commoner part is 2, so you write that 2 only once, and then 3 times 4, which gives you the actual LCM, 2 times 3 times 4, which is 24. 24 is definitely the first multiple of both 6 and 8, the common multiple. So I'm doing the same thing. I took out the commoner part and wrote it once, and I'll write the non-common part as it is. Thereby, the denominator of the first term did not get affected, right? This is the same. It is the same thing now. So I can go ahead and copy the numerator as it is. While my other numerator will be multiplied with the new denominator. If I'll compare, then this new denominator has 1 minus 2 sine square theta multiplied. Thereby, I'll go ahead and multiply this one again with 1 minus 2 sine square theta, because only if I'll do that, my denominator, new denominator will be satisfied, right? Because that is what you do. That is how I made the denominators common. So you can go ahead and simplify that bracket, or you can keep that cos theta as it is for a while, because I see the same cos theta appearing previously in the previous part of the numerator. Okay, so now again you have two things multiplying here. Check it out, these two are multiplying. So this is one term and this is the other term. Terms are always differentiated by plus or minus, okay? So don't confuse and don't say that there are more than two terms. Terms as in, if two things are multiplying, they are still one term. So two terms, okay? Added and subtracted, that differentiates the term. So cos theta seems to appear in both of them, so that is taken out common, giving me cos theta out like this. And then this 1 minus 2 cos square theta, I'll write it as it is. 1 minus 2 cos square theta is the non-common part. Similarly, here I have 1 minus 2 sine square theta divided by sine theta upon 1 minus 2 sine square theta. If you look at this now, the bracket part, you got 1 plus 1, which is 2. Now minus 2 cos square theta minus 2 sine square theta. Clearly minus 2 is common. If I'll take out minus 2, it gives me sine square theta plus cos square theta. Isn't that interesting? Because now I know sine square theta plus cos square theta is just 1. Now if this is actually 1, then all I got is 2 times 1, which is just 2, giving me 2 minus 2 in this bracket, which is the reason why the whole thing has now converted itself into 0, or it's just vanished, yeah? Because you have 0 multiplying with something 0, 0 divided by something is 0. So this has to be 0 is equal to RHS. They wanted me to prove that this whole expression is equal to 0. I just did that. I got the proof. So I'll just say hence proved. Yes, yes, hi, hello. Only meme, I hope that you get 90 plus. Why not? Why just 90? Aim for 100, come on. It is possible. Rohit, are you confused which part did I take common? We can take common anywhere you have plus or minus, and the two things do have something in common. Which part does not make sense? Okay, if we have sine theta is equal to 53 and theta is acute, find the value of cos theta. Sine theta is 53, find the value of cos theta. Sine theta is 53. Now find the value of cos theta. That's the question. Well, are they expecting you to do this without a calculator? If yes, then I would just say theta is, okay, well, I am wondering that because I don't know the value of 53, I mean I don't know the value of sine, I don't know for what theta the value is 53. Sine theta is equal to 53. Well, I think the question is wrong because sine theta cannot be 53. I mean, it has to be something less than 1. The sine value cannot be more than 1. I am sure that your question is a little, I mean, there should be something. Remember that sine theta cannot be more than 1. There is a logic behind that, and that is because sine theta is all about the ratio of the opposite or the perpendicular to the hypotenuse, and we clearly know that hypotenuse is the longest side. There is no way that this ratio of the opposite to the longest side can ever be greater than 1. Yeah, it was 3 by 5. Okay, yes, now that makes sense. Sine theta is 3 by 5. That actually makes a lot of sense, and I must tell you there is a very simple thing. I can do it for you because 3 and 5 are two common numbers we see in a Pythagorean relationship, because 3 upon 5 clearly means what? Theta is here. So with respect to theta, sine, if the angle is here, the opposite or the perpendicular is 3, then this is 5. Then what this has to be? It is simply done by, you can do this by simply taking your Pythagoras theorem, and you know Pythagoras theorem tells us that 3, 4, 5 is the most common Pythagorean triplet. So this side has to be 4, so cos theta simply has to be 4 by 5. If you want to show that by some kind of working, then you should always go ahead and use sine square theta plus cos square theta equals to 1. Sine square theta plus cos square theta is equals to 1. Then that clearly tells you, because you told me sine theta is 3 by 5, you can check it out yourself. 3 by 5 the whole square, if you subtract that from 1, should give you cos square theta, right? And again, see clearly 3 square is 9 by 25. If you remove 9 by 25 from 1, gives you the remaining of the two values in the fraction, which is just the difference here, 16 upon 25. Take the square root. Again, as I told you before, the square root of the trigonometric values should not be taken positive, negative, at least for now. In class 11, you will have to do that, okay? So for now, because you are learning only for acute angles, you don't have that negative value coming up. All the ratios are positive, okay? So cos square theta has to be the square of 16 upon 25, which is just 4 upon 5. I get the same answer before? Yeah, if something is not coming in your head, then always try the simplest, always go for the basic, which is the Pythagoras theorem. I hope that made sense. Only meme? Yes, I think I can see a signal that you are getting a 90%, more than that, because your answer is right. 4 upon 5. Somebody did ask me, how's the weather? Yes, Alan, yes, of course, the weather is very cold here right now. It's like not so cold, it's like 11 to 12 degrees Celsius during the daytime, and now maybe it's like 8, 9 degrees. So yeah, it's kind of like, I like this weather a lot, and you know, this is the weather I always like. Okay, no problem, Rohit, I can understand. This is the kind of question, this is the basic kind of question, okay? You have this kind of question where they give you sine theta and they ask you one of the ratios. Always use Pythagoras theorem. It is always helpful, all right? I am from Sikkim, only meme. So the weather here will be a little different. So this is exactly like currently the weather is actually cold. Yeah, it's different than other parts of India. So okay, it could be easy for someone, but I did do a lot of tough questions before this. This is just a requested question. So yes, I think moreover, this is the kind of question you should definitely expect during your exam, okay? This is the basic kind of question. If you are interested, then I would want to show you. If you are interested, then I can show you how the trigonometric table is derived. Do you know, like, why why the value of sine 30 is half and why 60 is root 3 by 2? And if you know it, then definitely I don't think I'll have to do, but if you are up for that, let me know, because I'm done with the questions now, and if you want, I can solve some of your queries. Like Rohit shared a question. If you have any problem to share with me, please do. Only Mim is up for this, Rohit is up for this. You want to know where is this root 3 and all these values coming up? Well, I'm kind of, even I did not know when I was in school, okay, but with teaching from a long time, I have had the privilege to understand this part. Well, it begins with, I think it's still the basic one, but it begins with taking an equilateral triangle. So let's say I have a triangle, equilateral, and in case of an equilateral triangle, I have the possibility of getting both 60 degrees and 30 degrees. Why? Because I know every angle will be 60 degrees each. So if this is 60, every other angle is 60 degrees, right? And now, I think you know this already, for equilateral triangle and isosceles triangle, when you bring a perpendicular height, then the height here will just bisect the side, the opposite side, like this one. This side will be equal. At the same time, it will also bisect the angle 30 degrees, okay? So now, each of these angles will be 30 degrees. So let's compare this. Now, if you have an equilateral triangle, then you know that this side, I'm saying that this mini side, okay, this half side is A, and this side will also be A. Then my whole side of the equilateral triangle has to be 2A, right? This is also 2A. So I'm only taking the right side of this triangle, or I'm just taking this side because I need a right triangle to use or to find out my trigonometric ratios, correct? So now the best part is I don't know, so in this right triangle, I know my hypotenuse, I know my base, but I don't know my perpendicular. So I will go ahead and use again the Pythagoras theorem. Pythagoras theorem will be very helpful here, and I know one of the perpendicular height is missing, so I just have to subtract, because hypotenuse is always the longest one. So from the hypotenuse square, I have to subtract this side, giving me 2a square is 4a square minus a square gives me 3a square. So now note that that's not the side, that's the square of the perpendicular. So the perpendicular side has to be simply square root of 3a square, which is simply root 3, because 3 is alone, so it will still be inside the root, while a becomes free of the root and becomes root 3a, or I can just write it as a root 3. Okay, either way it's the same thing. So I got my ratio that this side, this perpendicular leg, has to be a root 3. Now I think because of this, you can see how my sine angles can be, different ratios can be found. So sine 60 with respect to this angle 60 degrees, I know sine means to look at my perpendicular and hypotenuse. So perpendicular, I clearly got it as a root 3, and the hypotenuse was 2a, right? A and a cancels out, gives me, that should be always equal to root 3 by 2. So clearly root 3, if you were to find the value, it's 1.732, yeah, and it goes on and on. So remember that sine means it's always the ratio of the perpendicular to hypotenuse. So there is no way that the perpendicular can ever exceed the length of the hypotenuse. So it makes sense why sine ratio value of the sine ratio should always be less than 1. Okay, there is no way that value of the sine theta will ever go beyond 1. Now, the best part is, let's find cos 30. Yeah, to find cos 30 degrees, what will you do is simply cos 30 is now looking at this angle, and with respect to this angle, you see that the base happens to be the same thing as the perpendicular of the previous angle. So thereby, the base here is a root 3 divided by the hypotenuse. It gives me the same thing as I got for sine 60. That is the reason why we say that for two angles adding up to 90, the value, the sine of that angle and cos of that angle is always equal. Because you clearly saw that, right? Because in a right angle triangle, one of the angle is already 90 degrees, so the rest too has to add up to 90. So if you are looking through the perspective of this angle, whatever the perpendicular is now becomes the base when you look at the perspective from the perspective of the other angle. So thereby, why cos and sine flips their sign at different angles that add up to 90. That should make sense. Now similarly, if you were to find sine 30, then clearly with respect to angle 30 degrees, the opposite would be this mini side, right, a, and then hypotenuse is simply double. So that is the reason why a upon 2a gives you half. And now I think you better know that cos 60 is looking at those two same sides again, but with the perspective of the new angle, it should give me definitely, confidently half, because 60 degrees, the base is this a and the hypotenuse is 2a. And moving on, there is tan, they will ask you to find, so let's find for tan. Tan 30 means now tan is so easy because you just look at the two perpendicular legs. Opposite first, okay, opposite is a and this is a root 3. So thereby it just becomes a upon a root 3, which is 1 by root 3. And 60 degrees, again you have to find out, so you will look at, for 60 degrees you have to look at the new perspective or just change your perspective. So you look at this as the opposite or the perpendicular now. So a root 3 upon a. That is the reason why tan 60 is just reciprocal of tan 30, giving you root 3 as the answer. Now I did for all the angles, right, 30 and 60 both, but what about 45? When do you get that 45 angle? Is when you have an isosceles right angle triangle. So when the triangle is isosceles, that means the two legs are equal, and when the two legs are equal, technically hypotenuse will never be equal, right? It is the longest side. So if this is a, then the angles, both of the angles has to be 45 degrees. Now I think it makes sense to you why cos 45 and sine 45 are the same, because whether you look at, whether you look at the sides from this perspective or this one, it is going to be the same because the angle is same. Either ways you're looking at the base and the hypotenuse. So what's the hypotenuse here? Hypotenuse can be simply found out. The hypotenuse for a square, so this is like a diagonal of a square, right? You have the other two sides equal, so if you know, then you should remember that it is always equal to root 2a or a root 2. Okay, why am I saying this? Is I think I have done the proof before. Root 2 is, this is the first time how human beings came to discover root 2. Okay, if you have two sides, if you have a square and the diagonal of a square is always an irrational value. That's interesting, yeah? I mean, provided the sides are rational, okay? So if the sides are rational, then the diagonal is always irrational because it's always going to be root 2 times the side. You can do it by Pythagoras, you will get the hypotenuse exactly a root 2. And now, I think it makes sense why tan 45 is 1, because at 45 degrees, both the adjacent and the opposite are equal. It has to be 1, okay? And likewise, if I have to find the cos 45 or sine 45, it's like looking from any point or any point, like even if you look at the triangle from this point, the adjacent is a and hypotenuse is a root 2. giving you 1 upon root 2. Likewise for sine as well, if you look at from that angle or whatever angle, like whichever 45 you choose, it's the same thing, it's not making a difference, yeah. You are going to take a upon a root 2, opposite upon hypotenuse, again 1 by root 2. So this is how you get the different ratios of all the angles you want. And now this is the exact y. This is the exact reason why your trigonometric ratios for these angles are always often asked, because they are something you can easily derive using the Pythagoras theorem. All right. Now, all right, Alan. Yes, you're welcome. And the next topic will definitely be something else. I am trying my best to cover all the topics as soon as possible. I'm sure some of my class 10 students will have their pre-boards coming up soon. So I think this will be this will be helpful, yeah. And a lot of things will be coming further. And that is it for now. I will see you in the coming session. I'm sure it will be in a very different topic. So yeah, that is it for now, and I will continue in the next session. That's it for today. I will see you. Bye.